Good morning, guys. Today, based on a request I got from one of you subscribers to my channel, it's going to be an interesting one. I was asked if I could do the same quick speed test that I did on two of my previous videos. I will link to them in the bottom here. We have compared C# and Rust. Now, in the one case, the first test, I just used data types by name. So I used string in both C# and Rust. I just appended to it, and not the best thing you should do in the first place. And well, Rust was over 1,000 times faster than C#. But then, of course, C# you should rather be using a string builder, which I then did in my next video. And Rust came out to be something like 64% faster. Now the request that I got was that I do a .NET Core test. So instead of running .NET Framework in Windows and comparing it to Rust in Windows, I will be doing that this time anyway, but rather also do a .NET Core 3 app, version 3, and have that running on Linux directly, with Rust running on Linux directly. And I thought that's what we'll look at today. Okay, so I did change the test. What I've done is we in C# we're using the TPL to do threading. We've got here parallel 4. All right, so we're going to be using 4 threads to do a very expensive function calculation. Okay, it'll just tell you up top here that it's in the thread, so we should see on the screen it says to us in the terminal 4 times in thread. Okay, then what it'll do is it'll run through this loop 500 times. Okay, and what it does is it basically just takes an array, all right, a generic array. It initializes it with integers from 1 to 80,000, so 80,000 elements in the array. And then it goes and selects out of that array only the even numbers, all right? So we had an initial array of 80,000, now only the even numbers, so we should be dropping to about 40,000. Then we sum up all the even numbers, okay? Then we get the average of all the even numbers, okay? Then we go to the even numbers array again, and we only extract those elements that are larger than the average, okay? So we should at least have half the size of our even number again in larger than average array. Then we sum the entire larger than average array up, and then we calculate the average of that, and we've got a little counter up top here. We just keep adding to it. The main reason why I did that is I think when optimization gets done, especially in Rust, if you don't use a variable, for instance, like I used to end here, because average is never used, it might not actually do this calculation, even though it's such a lightweight calculation. I just thought I'll force it to happen anyway by actually using the variable and returning it. I never actually use it though. Okay, this is the exact same code. Okay, we're looking at .NET Core 3 at the moment. Okay, this is the exact same code. I just copied and pasted it, and I stuck it into .NET Framework. The exact same code. All right, they both in release mode, x64 optimized. Okay, and all right, so the first one we'll do is we'll run our old the previous benchmark application, which has now been replaced with a new one. Okay, so we in release mode, and I'll control F5 it, and it's running. There it says it's in all the threads, so we've got 4 threads running, and it's taken 5.6 seconds. Okay, I think just for fun we'll do that again. So it's 5.6 seconds. Okay, it's running. 5.2 seconds. Okay, let's just keep a tally of that. Okay, we'll just open a notepad here. So it's normal framework was 5.6 seconds and 5.2 seconds. Okay, for our 2 runs. Then we'll have core as well. All right, we'll see what data will give it 2 runs as well. Okay, so we can close that. So it's about 5.4 seconds on average for .NET Framework. Okay, this is also the latest. I did a full update of my computer 2 days ago, Got the latest of absolutely everything. Even Windows is the absolute latest. Also made sure my antivirus is switched off for this test, etc. I've got nothing else running on Linux other than just my OBS to do the recording, and Visual Studio Code, and then the virtual machine which we've got now. Okay, so that was the normal .NET framework, so say 5.4 seconds to do it. Okay, so now let's do .NET Core 3. .NET Core, why did it show that now? I'm not interested in showing you that. I just want to make sure, because if I say Control F5, okay, so now we're on the .NET Core one, all right, and we're running it. Okay, it's in the different threads, and it should be slightly quicker, I think. 5.1, all right, so it's already quicker than .NET Framework's fastest. Okay, so that's 5.1, all right, we're going to run it again. Let's go again. Okay, it's running, it's in the thread. And 5.5. Okay, so that one was a bit slow. Normally it's faster. I know I'm cheating a bit by giving it an unfair chance, but I'll give it one more go. 5.5. Okay, well maybe that's more or less where it is. So okay, let's just stick that in here as well. Okay, so this was about 5.4, and this was about just under 5.5, so also about 5.4, I'd say. All right, so framework and core, both of them running in a virtual machine is 5.4 seconds to do our little multi-threaded test. Okay, now the exact same application, all right, just written in Rust. Okay, it's literally the exact same except for, all right, a little detail I'll tell you about now. But if you really look over that code, okay, the problem is the fact that when I originally wrote this application, I used unsigned 64 bits integers, okay, because I wanted to do some really large calculations. So this number over here in the loop, okay, it was in the millions, okay, and you need 64-bit for that, so that when it does its the sum, when it sums up the arrays and so forth, these numbers are bigger than what a unsigned int32 can handle. But I had to bring it down because of the fact that C# can't handle in some of its methods these unsigned U64s. So if we go back into the virtual machine, if we go to Windows, you'll notice I tried to use, where am I declaring? So like, yeah, all right, that's just an int64. It's not an unsigned int64. The reason is because sum, for instance, only returns back an int, okay, and an int could be negative, all right. So it doesn't work with unsigned numbers. It requires a signed number, okay. So now, for speed reasons, I could have done a lot of these things, like extract the even numbers out of the arrays myself, do the summing myself, just run through loops and so forth, and then I could do it. But that'll slow things down so much. I decided rather to stick to the fastest possible way that the framework allows us to do manipulation with, we'll call arrays, or generic lists. In this case, it's an enumerable of type int. Okay, so it's also much less code now, but this is the only way, this is the fastest I could possibly get it, was to use these actual built-in functions of the enumerable generic list. And that means that I cannot change this number, okay, into the millions, okay, because it just uses up all the memory on the machine, and the VirtualBox just crashes. When I go to Rust, I don't have that problem because it can handle U64s. I might show you just now how we crash the VirtualBox. But okay, so let's just quickly run the Visual Studio Code one. Okay, it's also just in release mode. All right, it's running in thread and it's finished. Okay, it took 332 milliseconds. Okay. Not 5.2 seconds, 332 milliseconds. All right, we'll run that again. 361 milliseconds. All right, let's stick that in here. Okay, and we'll say Rust what did I say? That was where is it? 361, 330. Let's say 350 milliseconds just for the hell of it. Okay, 350 millisecond. All right, so I mean you can really look at that percentage difference there. Okay, we'll just say that this is in the virtual machine. Okay, and down here we have I just called it live. All right. Then okay, so that's basically it. So what I went and I did is with .NET Core is I actually installed .NET Core 3 on this Linux box. I wanted to use the framework installed itself directly instead of having everything in one folder. I just wanted to test it. So in other words, when I did a release or a publish of my benchmark of my .NET Core app, okay, if you go to publish, all right, I did specify target is portable, and I said that it's release mode. I didn't specify anywhere that it must include the entire framework that it needs and so forth, because that's already installed on Linux. Okay, now I know a lot of you Linux guys are not going to want to install the .NET Core, and as far as I know, you don't need to if you include everything in the same folder when you do your publishing. But all right, so okay, so we basically finished with the VirtualBox. Oh, sorry, so I did that build, and then using FileZilla, I copied that build over onto my Linux box. Okay, so on the Linux box, I've actually got the release executable, okay, of the .NET Core application with the exact same stuff that's inside here, no difference whatsoever. But anyway, so we've compared Rust to .NET Framework and .NET Core on Visual Studio with basically the exact same code in .NET Framework and .NET Core, and the equivalent of that in Rust. Okay, so let's kill the virtual machine. So we've got all our processing power available to us. Okay, and we'll just do a shutdown here quickly. Do a nice pretty shutdown. Okay, shutting down. Okay, come on. What we can do is get the calculator so long. We can just do a calculation quickly of how many times. So that is, where are we? Okay, so if we take, so that's 540 divided by 350. Okay, so that makes Rust 15.4 times faster than .NET Core and .NET Framework running in Windows, same virtual machine, 4.1 gig RAM, 4 cores, etc. So about 15 times faster. Okay, now remember that number, 350 milliseconds. Okay, is Windows closed yet? Still true. There we go. Okay, it's gone. Okay, so if we come here now, okay, so this is the exact same code. I copied and pasted it out of the virtual machine. Okay, so now it's running on Linux locally. So it was 350. Last time the virtual machine didn't make that much difference for Rust. Let's see what it does this time. Okay, so let's just run it again, release mode, and it's done. 162 milliseconds. Okay, twice as fast as the virtual machine. All right, again, 187, 210, 168, slowing down, 181, 206, 185. Okay, so we're hovering in around about the 200, 190, around there. Let's say one more try. 186. Let's say 190. Okay, just to be safe. All right. So live Rust is 190 milliseconds. So more than twice as fast as in the VirtualBox. But of course, that's to be expected. I mean, of course, it's not going to run as fast. Okay, so yeah. This is where I've got now the actual .NET Core app, which I've now downloaded and I stuck it onto Linux directly. We're in Linux itself. No Windows is running. The .NET Core framework has been installed, runtime only, sorry, not for development, just runtime. All right, so what we were looking at, 5.4 seconds approximately in the virtual machine. Let's see what we get here. Okay, 4 threads running, and 3.4 seconds. All right, we'll run it again. 3.7, and finally, no, that's a bit of an outlier. Let's give it another chance. 4.2 again. 4.4. Okay, it seems to be hovering in the vicinity of about 4, I would imagine. 4.5. Every single time it's getting slower and slower. Don't know what's happening with the... Yeah, there, that's better again. It might be the garbage collector that has to do stuff in the background. I don't know. But okay, so let's say 4.2. All right. So okay, so core is 4.2. Okay, so and we did the Rust one. Okay, so if we just take that calculation, sorry, just give something in the background there. Where's my calculator now? All right, so on Linux itself, okay, so we have 4200 divided by 120. On Linux itself, Rust is 35 times faster than .NET Core. Okay, that is substantial. I mean, think of traveling at 100 kilometers per hour and someone shooting past you at 3,500 k's an hour. It's ridiculous. Okay, but all right. And like I said, I tried to optimize that the .NET framework code as much as I possibly could. You know, we're so used to often doing things in generic lists and so forth by manually looping through the list and adding things up and calculating things and so forth. And I try to use the features. When I noticed how to do it in Rust, I looked at C# to say surely there must be similar ways, and I found yes, there are these much faster ways of doing things. And yes, Rust again came out on top. This was now multi-core. Yes, I do know about Tokyo and so forth for Rust. I did choose to stay with the standard library in this test. But yes, we could even optimize things more and so forth, and thread pools come into it, etc., etc. But yes, so that's my current conclusion. Rust still is much faster. But again, remember, we're comparing apples and oranges here. Rust is a systems level a development language. C# is not. Okay, Rust does not come with the entire framework stuck behind it. C# does. Okay, that makes C# very easy to use because you always know you've got certain libraries available and so forth, and they will be pre-installed on computers and so forth. That makes your executables very small. With Rust, all these things get compiled into one library and so forth. There are sometimes dependencies, like you might need to talk to MySQL, etc. You need the library installed for that. OpenSSL and so forth, but in general, you know, everything is compiled into one executable. I've heard that the .NET Core guys are now working on when you publish your .NET Core app, that they're also going to release only one binary. That's in the workings. I don't know when they're actually going to have that done. But yeah, so yeah, I'd love to say more, but I don't really know what to say.